You know, some parasites have come up with some truly wild ways to survive, but I'm willing to bet you've never heard of one that literally weaponizes the air around it. Yeah, we're talking about a microscopic hunter that uses a totally invisible force to snatch its prey right out of the sky. I mean, really, think about it for a second. Whatever you've got going on today, I can pretty much guarantee it is a whole lot better than what some unlucky insects have to deal with. Just picture this. You're a fly. You're just buzzing along, minding your own business, maybe thinking about landing on a picnic lunch somewhere, when all of a sudden you get pulled sideways by something you can't even see. It's like you've been caught in some tiny, invisible tractor beam. That's right, a worm. A worm just snatched you out of midair. How is that even possible? Well, nature has a few tricks up its sleeve, and this one is a real shocker. So what is this thing? This tiny, terrifying, grappling hook of a creature? Let's go ahead and meet the star of our show. Everybody say hello to the entomopathogenic nematode, or, EPN for short. Specifically, we're looking at a species called Steinernema carpocopsi. It's a microscopic roundworm, only about 400 micrometers long, that lives in the soil and has let's just say, a very particular and very brutal way of making a living. Okay, so to get why it has this bizarre hunting method, you first have to understand the high-stakes world this little worm lives in. For an EPN, finding a meal isn't just about getting lunch, it is quite literally a matter of life and death. So here's the game plan for this worm. At this particular stage of its life, it can't eat. Its one and only mission is to find an insect host. To do that, it stands up on its tail and launches itself into the air, jumping more than 20 times its own body length. If it lands on a host, it releases these deadly symbiotic bacteria that kill the poor insect in about 48 hours. Then the worm and its babies feast on the liquefied remains. And if it misses, well, it just starves to death. So, no pressure. So how does this tiny worm possibly improve its odds? How can it hit a moving target in midair? Well, the clue is in an invisible force that's all around us all the time: static electricity. And what's wild is that using static electricity is surprisingly common out there in the animal kingdom. Bees, for example, build up a positive charge that helps pollen literally jump onto them. Some spiders use electric fields in the atmosphere to balloon for miles. Mites can sense the charge of hummingbirds to hitch a ride, and recent research even shows that ticks can get electrostatically pulled onto animals that walk by. Our little worm isn't alone. It's just taken it to a whole new, terrifying level. All right, let's get into the physics of this. How does a microscopic worm turn a basic science principle into a precision-guided weapon? The secret is something called electrostatic induction. Basically, when a charged object, like a buzzing insect, gets close to a neutral conductor, like our worm, which is wet and touching the ground, the charges inside that conductor separate, and that separation creates an attraction. It breaks down into 3 simple steps. First, a flying insect, which naturally builds up a positive charge, flies overhead. This polarizes the worm. It pulls all the negative charges up to the tip and pushes the positive charges down. Second, because the worm is touching the wet ground, all those positive charges flow away, leaving the worm with a net negative charge. And then finally, the worm leaps. Now it's a negatively charged projectile that's irresistibly attracted to a positively charged target. It literally gets pulled toward the insect in midair. Okay, I know, this sounds like something straight out of science fiction, right? But researchers actually proved it with some incredibly clever experiments. Let's take a look at how they figured this all out. In their control experiments, where there was no charge on the target, the worm would just jump and fall. Basic physics, a simple arc. But when they gave the target, in this case a poor fruit fly tethered to a wire, an electric charge, the worm's path would visibly curve through the air, homing in on the fly like a tiny heat-seeking missile. And the results? The numbers are just staggering. Without electrostatics, only 1 out of 19 worms managed to hit the target. That's a 5.2% success rate. But with that tiny static charge, every single worm, 19 out of 19, hit their mark. A perfect 100% success rate. This isn't just a small boost. It's the entire difference between eating and starving. And if that wasn't already weird enough, the researchers found another twist. You'd think wind would make this whole thing harder, right? Wrong. Their simulations show that a gentle breeze actually helps the nematodes. It lets them drift farther, extending their range and giving that electrostatic pole more time to work its magic. Incredible! So what this means is that this discovery is way more than just a single worm's creepy party trick. It's cracking open a whole new field of study some are calling electrostatic ecology. It suggests there's this entire invisible layer of physics shaping life and death struggles all around us. It makes you wonder who else is using these forces, and how has it shaped evolution on a microscopic scale? We're just scratching the surface of how the world is truly wired. Come on, we've all done this, right? You rub a balloon on your hair to make it stick to the wall. It's a classic kids' party trick. Well, when you do that, you are using the exact same physical principle, electrostatic induction, that this tiny parasite uses to yank its dinner out of the sky. It's a fundamental force of nature, just weaponized by an organism you can't even see. It really makes you wonder, doesn't it? If microscopic worms are out here using static electricity as a grappling hook, what other invisible forces are playing these huge roles in the tiny dramas of life and death that are unfolding all around us, completely unseen? Nature is just so much weirder than we can possibly imagine.